Okay, cool. So here we have question 3. So it's quite a bit of text to read. So 12 students in a class are each given a square card. The side length of each card is a whole number of centimeters from 1 to 12, and no two cards are the same size. Each student cuts his or her card into unit squares of side length 1 centimeter. The teacher challenges them to join all their unit squares edge to edge to form a single larger square without gaps. They find that this is impossible. Alice, one of the students, originally had a card of side length 8 centimeters. She says, if I don't use any of my squares, but everyone else uses their squares, then it is possible. Bob, another student, originally had a card of side length B centimeters. He says, me too, if I don't use any of my squares, but everyone else uses theirs, then it is possible. So assuming they're correct, what is AB? Okay, so let's have a look at the side length of each card is a whole number of centimeters from 1 to 12. No two cards are the same size. That's the same as saying every side length is used. So we have side lengths 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. Now for each of these, the area and correspondingly the number of unit squares you can get from it is the square of this, right? So we have just 1 unit square for this one, 4 for this, 9, 16, 25, 36, 49, 64, 81, 100, 120, 121, and 144. Okay, so now the teacher says put them all together and make a square. So that means basically you need to fit in all these unit squares into a larger square. That would require you to, take the sum. Yeah, that would require you to take the sum of these unit squares, right? Like if you want to fit in all of these, you have to take the sum of them, right? And in order for that to be a square, you need the sum to be a square, right? So let's actually calculate what the sum of all these is, right? So I'll just do a cumulative sum because I find that this is probably easiest. So 1, 5, 14, 30, 55, 61, 81, sorry, 91, 140, 204, yeah, you're supposed to add all of these without a calculator. So like, I hope I'm showing you that it's not too hard to add all of these without a calculator, right? Like it's a pretty quick process as long as you know these very small squares, right? Like surely you know your squares up to 12, right? And you can add 2, 3-digit numbers. So it's not a very long process to do this. Like we've just done it in 2 minutes. $650, right? Okay, and clearly 650 is not a square number, so the students are correct. It's impossible to fit all their things into a square. And so Alice is saying that if she removes her number, no, you just have to bash through the numbers. Well, I mean, maybe there is. I don't know it. So yeah, Alice is saying that if she gets rid of her number, then she can get a square. And Bob is saying if you get rid of his number, you can get a square. So we have to find two numbers such that if you remove their square, 650 becomes a square. So really, like, we just have to look at the squares that are less than 650. What's the closest square less than 650? 625, right? I'm sure most of you know that 625 is just 25 squared. I'm recording, right? Yeah. So 625, but that is exactly 650 minus 25, right? 25 is 25 is just 5 squared. So we know that Alice's number, or Bob's number, doesn't matter which one. Alice's number is 5, right? Because we get a square by taking away 25. And similarly, let's go down one. We have, what's the next square underneath? It's 576, right? 24 squared. 650 minus, well, this is, to find out what the difference between this is, what's 650 minus 576? This is 74, which is not one of these squares, right? So this is not the square that we need. What's the next square underneath this? I think it's 529, right? Yeah, but I mean, you have to prove that. Well, no, sorry, you don't have to prove that. What am I saying? Yeah, you can just memorize this formula if you want for the sum of squares. Okay, so the next square down is 529. This is exactly 121, which is a square. So this is 11 squared. So we have Bob's number is 11. And so we have AB is equal to 55. Yeah, this is a bash. I mean, there's things you can do to make it like nicer. Like you can note that we have to do 650 minus like 144. Like that's the biggest thing we can get rid of. So the square that we have to consider is at least 506. So we only have to consider like these three squares, right? So it's not a very big bash. Is there an algebraic method? In what sense? You have like, yeah, this took like less than 10 minutes to do, right? Just sheer speed arithmetic. Yeah. I mean, like each step is kind of straightforward, right? Like as long as you don't get scared of the fact that you have to just add up these numbers, like it's like each step is kind of straightforward. Michael, do you have any comments? Or does anyone have questions and comments?
Yeah, I guess like the best thing you can do with this question is just have the most efficient way of figuring out what values to test. So like, yeah, so like Aayush said, we're only going to be able to take away one of the squares from 1 to 144, which means that you want to try subtracting the squares that are bigger than 506, which is 650 minus 144. So that sort of thing, yeah, already like takes a
Limits
lot.
our cases.
Yeah, and because the squares become so much more further apart as you get bigger in the numbers, knowing that it's restricted to that should sort of give you a lot of comfort already, because you already know there's only going to be like 3 squares that you really have to test. And then there are other methods you could, I mean, if you see this sort of thing quickly, you could realize that that like both the square that you take away as well as the square that you're left with are odd, and then you only test like every second number or something.
Yeah. Michael, any comments?
Yeah, so I have some comments. So the statistics for this year was that more people got this question right than one or two. So I think people were more comfortable writing down numbers than they were writing down letters. Um, yeah, especially the smart people who don't know any maths and give up easily. Um, so it was worth 3 marks. Obviously, if you got the right answer, you got all 3 marks without any of your proof or working being checked. But um, there was 1 mark given for adding up all the square numbers. Okay. So there wasn't that many ways to do it, I guess. So and then there was another mark given for sort of restricting the possible values um, of the 2 numbers that you're trying to find. So maybe like reduce it to a couple of possibilities. Um, maybe even find them, because sometimes you find them and you write down the wrong answer. But like, so there's a question. So you might see this. This actually doesn't come up that much, but it comes up in this question. So it asks you for what A times B is, right? So when it asks you for A times B, some of you might be tempted to think, oh, is there something special about the product? Or am I just meant to find both of them and times them together, right? So the second option is probably the more normal one. So the reason they do A times B is because you can only write down one answer in the answer slot, and it has to be between an integer between essentially 0 and 1,000. So they kind of it's kind of an artificial way to construct an answer that you can write down, as opposed to necessarily having any mathematical significance. Do you know what I'm talking about? Microphone check.
Hello.
Yeah. So sometimes they'll ask you for A times B or A plus B or something, but like it's not really because that's special to the problem. It's more that they just want to get one integer as the input answer. Okay. All right. So about 2/3 of the people got this correct. 1,600 out of 2,500.
Yeah, I'll just keep recording. You can
Yeah.
present
Okay.
yours.
Oh wait, you can stop because now I'll start like right after you stop so that I don't forget.
Forget.